Hi everybody, and welcome to tonight's video where we are going to be talking about building models from data. In the previous section we were already given a model that was in linear function form. So we had something like, for example, c of p equals 3p plus 15, and this is a linear function model, right? So remember, the function represented something like cost, and P was like the price of a phone. So like if it was the cost of a phone plan, we'd insert like the price of the phone to begin with, and then it was 3 times P maybe per month or something like that, plus like a startup fee, right? So this was a function that modeled the scenario. It was a linear function because it's in linear function form. So it's something like f of x equals mx plus b. Right, in this case, the function is called c instead of f. The variable is p instead of x, but there's still a slope, which in this case was m, which is p, and there's still a y-intercept. In this case, it was 15. So it still follows a linear form. Okay, so we were given the function and could plug in different values for p to evaluate the total cost. What we're going to do now is work backwards. We're going to be given some data. So we're not given the function, but we are given data, and we're going to use that data to determine the function and build our model. So instead of being given this scenario, we might be given the different prices of different phones and then the total cost of the plan, and then we'd have to plug in, or we'd have to use those data values to determine a linear function like this. Okay? So there's 6 steps to doing that, and what we're going to do is just write out general examples for that, and then tomorrow we're going to start class using these 6 steps with a specific example of how to build a linear function. So the first thing that I want to do is plot all points from the data set, and I'm going to plot them on a coordinate plane. And the way that I'm going to do that is use this table, because usually the data set's going to be given to us in the form of a table, and each one of those values is going to correspond to an ordered pair. So even if we're not using our, let's say we're using 2 different variables like we did in our example before, where P represents the price of the phone and C represents the cost of the entire plan. Whatever is in this column here represents an x coordinate, and whatever is in this column here represents a y coordinate. So together, these would make up an ordered pair, right? So every point in this table represents an ordered pair that I can plot on the coordinate plane. So once I do that, once I plot all these points from this table, what I do is I determine the data trend, because I'll have something that's called a scatter plot. And a scatter plot is basically a plot of a bunch of different values, right? So I have maybe these points, 1, 2, 3, 4, 5, 6, 7. These 7 points represent 7 entries on a table, right? And so there are all these points here that are part of my data set. Now in the last section, what I would have done to determine if this function was linear or not is I would have compared all the delta y's and delta x's to make sure that my rate of change was consistent between any 2 points. But here we're not going to do that. So that's something to write down on the side. We're not using the average rate of change here to determine whether or not our function is linear. What we're going to be doing now is using this scatter plot. And what we're looking for is not that consistent rate of change, we're just looking for a general trend. Okay, and so the trend is what the general idea is of what these data look like, what these data points look like. So if I were to think what would continue here, it would probably continue to go up and increasing from left to right. And so this looks like it's linear to me, right? If I think about what the general trend is, this is a line going, increasing from left to right. Okay, so I would say that that looks pretty linear to me, and so we would be able to continue with our 6 steps. But if I had something that looked like this, maybe I plot all my points from my table, and I see that the general trend looks something like this, where it's not quite linear, right? If I were to draw in a general pattern for this, it would look something like this. It would be more parabolic, right? And so we're going to get to that later on. We will model data values like this, but for now we would just think, we just want to know if this is linear or not so that we can continue with this process. Here this is not linear, right? So what we're doing is we're using the scatter plot, we're using what this looks like in general, a trend, rather than the actual average rate of change to determine whether we have or not we have a linear model. So if I see this general trend and it's linear, then I can continue. And step number 3 is to draw the line of best fit. Okay, so here I kind of drew a line of best fit. And step number 3, let's be a little more specific. So if I have a set of data that looks like this, and let's just draw this in here like that. I'm going to actually copy this so we can do 2 different lines. So let's copy and paste it in right here. Okay, so I have these 2. This is 2 examples of the same set of data, right? What I want to do now is I've already identified that this trend looks like it's linear. It's increasing from left to right. What I want to do now is draw the line of best fit for my model. Okay, now if I draw a line that looks like, let's say it looks like this, okay, that line kind of represents my data in that it's linear and it's increasing from left to right. But if I think of this, I really want the best fit, right? So this isn't necessarily the best fit. I notice that there's 1, 2, 3, 4 points of my data up above this line. There's only 1 down below it. The idea is hopefully I can intersect 2 points to represent my data. That would be great. If not, as long as I can determine 2 points that are on like 2 absolute or exact values of the coordinates of points, that's fine. If it hits 2 points of the data set, that's even better, but it doesn't necessarily have to. But still, this line is not a best fit, right? It's kind of represents the general trend in that it's linear and increasing, but it's not the best fit of my data. The best fit of my data would be something like this line here, where it kind of evenly splits the data. There's a few points above, a few points below. It's not always going to be exactly even above and below. But in this case, it seems to fit the general trend of this data a little bit better. So here, the slope isn't steep enough to represent this general trend of data. If I were to continue the scatter plot, I think the points would go up like up here. In this case, the line of best fit goes to, it's too shallow. The slope isn't going to match up my future data values. Here, this seems to be a line of better fit, or a line of best fit, in that if I follow the slope of this line, I think the trend of the data will follow pretty closely with that, right? So now I have the line of best fit. So this is not best fit. I wouldn't want to use this one. I'd want to use this one. And once I have that line of best fit drawn in, I'm going to use 2 points from it to determine my linear function model. So like I said, if it hits 2 points of your data, that's great because you'll know the exact coordinates of those points from your table, right? Because you've already plotted these points from the table. You can use those. But if it doesn't, you can just use any 2 points that are on this line, as long as, you know, it's easiest if you know their exact x and y coordinates using your coordinate plane, okay? So once we have 2 points that are on that line of best fit, we can write the equation for it, right? Because those 2 points would represent x1, y1, and x2, y2. And if I have 2 points, I can find the slope of the line, right, is y2 minus y1 over x2 minus x1. So once I have the slope, I can put that in point slope form. So I'd have y minus y1 equals m times x minus x1, right? So if I have 2 points from this line, let's call this x1, y1, and up here I have x2, y2, I can now plug in those values here and determine the linear equation, right? So that's step number 4. We're building the model using our point slope form and our slope. Then step number 5 is to convert that over into y equals mx plus b form. So I would distribute the m, move over the y1, and simplify everything to get into y equals mx plus b form. And then finally, what I'd want to do with that is convert it into my linear function form. So remember, if we have our function is represented as c of p, we'd want to take whatever we have, y equals mx plus b, and just translate it over into whatever our function is. So in this case, it was c of p equals mp plus b. So just make sure you're using the right variables. And now what's convenient with that is we can predict our future entries in the data set. So we could plug in future values of p to evaluate this function. Okay? So these are just the general notes I want you to bring with to class tomorrow. There's 6 steps. If you have any questions about this, bring them with you tomorrow. These are just general ideas behind the 6 steps for graphing or determining the linear function model, and tomorrow we'll start with a specific example. So for class tomorrow, what I want you to do is bring your notes with these 6 steps, and you're going to have your notes open as we work through an example. So have graph paper ready, because we'll need to use the graph paper to build our linear function model. And have that ready to go either in your notebook if you want, or have it on a separate piece of paper that you can put into your notebook, because we're going to have these 6 steps on the side. We'll go step by step with a specific example, and we'll do that example on graph paper. So however you want to organize this in your notes, just make sure you have graph paper and these 6 steps. Also, what I want you to do is email me with topics that you are interested in. So things that we're going to be doing this topic of modeling throughout the year, and a lot of the ideas or a lot of the examples in the book are like sports related or something like that, so it might not be the most interesting to all of you. So if there are topics that you are interested in, so something that you might be wanting to major in college, or things that you see in the news that you want to know more information about, we can look up some data and use those possibly to build our models. So let me know what you're interested in, and I'll try to make up examples that use those. And then the last thing that I want you to do is bring your graphing calculators, because the graphing calculator has a function that will do step number 4 for us. So we can enter in our table values in our calculator, then use something that's called a linear regression function to determine the line of best fit, and then we'll be able to plug in values there. So there is an option to do this on your calculator, so that's why I want you to bring your calculators tomorrow. Okay, so have a great night, and I'll see you tomorrow.